Welcome back to the AdBlue System Design Series. In these videos, I walk you through how each part of the installation works, from tanks, pumps, and piping layouts to instrumentation, safety requirements, and overall process logic. My goal is to make the whole system easy to understand, even if you're not deeply familiar with industrial design. Step by step, we'll build the full model, explain why every component is needed, and show how everything connects in a real production setup. Let's begin. Here I'm adjusting the water tank pipeline to create a clear and safe maintenance area. The goal is simply to organize the lines so technicians have enough space to access valves, instruments, and the tank itself without obstacles. The second task is to sort out our product discharge pumps. They don't have discharge lines yet, so here we simply copy and extend the existing layout to complete their piping. These two pumps work as the main and the reserve units. Since they are relatively compact, we can reduce the spacing between them and free up some area around the installation. Just a small jump to another line. The strainer outlet should be oriented downward, so debris can settle properly in the basket-type filter. Another issue is that the strainer end is positioned too close to the drain valve. The opening at the end may block access, making it difficult to operate the valve. So we need to adjust its position for proper clearance. I'm shifting the pump slightly backward to create better spacing and improve overall accessibility. Here I'm adding the drainage valves to complete the line and ensure proper emptying during maintenance or shutdown. Let's finish the discharge lines. One pump feeds the truck loading unit outside, and the other pump fills the storage tank using hoses. Both lines can operate at the same time, so the pumps work independently from each other. Now I'm adding a pressure gauge on the discharge line. This instrument lets us monitor the pump's operating pressure in real time. It helps detect blockages, abnormal resistance in the line, or any pump performance issues. During maintenance or startup, the manometer also shows whether the system is properly primed and running within the safe pressure range. The discharge pumps also need basket filters to ensure they deliver clean product to the outside system. These filters trap debris and protect both the pumps and the downstream equipment, keeping the flow consistent and preventing blockages. Let's add pressure gauges in both sides of the filters. With pressure gauges on both sides of the filter, we can easily see how well it's performing. When the filter begins to clog, the pressure on the inlet side increases because the flow meets more resistance entering the filter. At the same time, the pressure on the outlet side decreases as less product can pass through. The growing difference between these two readings is a clear indication that the filter needs cleaning or replacement. I connected the filters with a pipe so we can switch the pumps between truck loading and hose filling. This setup gives flexibility. Either pump can serve either line, depending on what operation we need at the moment. Both lines need flow meters, so we can accurately track how much product is being transferred. On the truck loading line, the flow meter shows the exact amount delivered to the truck. On the hose filling line, it helps control and record the volume pumped into the storage tank or containers. Having flow meters on both lines ensures precise dosing, proper documentation, and easier monitoring of the whole system. Now let's add pressure gauges on this filter to monitor its performance more accurately. The same principle applies here as before. We place pressure gauges on both sides of the filter to see how its condition changes during operation. This pump is not just a reserve unit. It also has its own dedicated line for pumping AdBlue from the drainage hole, the sump pit. So we just stretch line from the elbow. I'm just moving this unit to the left side to create free space for the pressure gauges on the suction line. I'm also adding gauges to the pressure lines and secondary filter as well. I'm simply extending one line from the reactor outlet and connecting it to the discharge pumps. This allows us to take AdBlue directly from the reactor and pump it to the outside as needed. When this option is not needed, we simply shut the valve off. I'm adding one more branch on the discharge pump inlet side, with the other end connected to the drainage pit line. This allows us to pump waste from the pit into a plastic container whenever it needs to be emptied. This pipe path looks chaotic now, but we'll tidy it up later. This pipe routing looks like a disaster to me right now, but every project has to start somewhere. We improve it step by step until the whole unit becomes clean and efficient. By the end of this project, all pipes and equipment will be in better positions. It just takes observation, adjustments, and sometimes learning from small mistakes. It's very hard to complete a project without adjustments. You can place equipment where you think the positions are good, but later you often need to move it because the pipes are too close, access to nozzles is uncomfortable, or maintenance space is missing. I'm adding one more pipe to the top of the reactor. It's used for returning AdBlue for mixing with water or urea, or simply for recirculation. And that's it for this part. We've added the main lines, arranged the pumps, and connected the reactor with all necessary branches. In the next videos, we'll continue refining the layout, improving pipe routing, and adjusting equipment positions to make the system cleaner and more efficient. Thanks for watching, and see you in the next part.